Yeah, and I'll be introducing you guys to Solidity this evening. So, first of all, I want to ask, how many of us are developers, like Web2 developers, have been developing Web2? Can you signify? Hello, hello, hello.
Uh, so you can go ahead, right? I think, guys, you guys should respond to ask questions and all of that.
So I'm
When it,
asking,
Uh, All right,
is there
I
any
can
Web2
hear you.
developer here? Like,
No, I'm not. Someone should answer if there is any.
okay, in the absence of none, let's just start. So, I'm going to share my screen so that you can see the slide I prepared. So, this is the slide. So, let's start with uh, the difference between, oh, let's start with programming first. Programming in general. So, what's programming? Programming is just about giving the computer instructions to execute. So, there are a lot of ways of giving instructions to computers. It can be through text-based, can be GUI, and so on and so forth. Example of GUI is Scratch programming. For example of text-based programming are JavaScript, Python, and so on and so forth. So programming basically is giving the computer instructions to execute. So that's what programming is. Now we have Web2. We also have Web3. What is Web2? What's Web2? What's different between Web2 and Web3? Web3 is the traditional, way of building applications. So when I say traditional way of building application, what I mean is this: you create an application and somebody manages it for you. You create an application and one person will oversee the application. The server is going to be under the care of one person. So that's Web2. That's how Web2 works. But Web3 on the other hand is it follows another approach, it follows a different approach, which is called decentralization. So what do you mean by decentralization? It simply means that we are no longer giving the whole power to one person, like in the case of Web2. So Web2 follows what we call the client server architecture, where everything is going to be managed by just one organization. Example is Facebook. All our data is with Facebook. We also have Google. Google also manages all our data. You understand? So that's the traditional way of building applications. But then, for the sake of transparency, for the sake of what transparency, we needed to be able to build applications that we all can see. Everybody can see that okay, oh, this is how this thing is running. Because talking about Web2 applications like Facebook and Google Meet and Google rather, you don't know what's going on behind the scenes. You don't know how their code is running. You don't know if they are doing anything. You know. So I mean, are you getting it? You don't know because everything is hidden away from them. Things are abstracted away from them. So Web3 has come to take away all those challenges, all those problems. So by making us develop apps that we can we can see have like a transparent in the sense that can see the source code. So what I mean by seeing the source code is that, remember earlier, I said applications that are built in Web2 are not usually transparent. Transparent in the sense that you don't know what's going on behind the scene. You don't know how the code is working. Are you getting it? You don't know the manipulations they are doing on code while it is working. But Web3, on the other hand, gives room for transparency. You can tell that, okay, this is how this code is running. You have programming knowledge. So that's basically the difference between one Web3. So let's move on. So in this course, talking about Solidity. And Solidity is a programming language that is used for writing smart contracts. So earlier on, I mentioned Web2. Example of languages we use in writing Web2 are JavaScript, Python, C, C++, Rust. We use Rust for Web2, and so on and so forth. But when it comes to Web3, when it comes to building smart contracts, that's a language that are typically designed or created for to serve such purposes. And one of the languages is Rust and Solidity. So we're talking about Solidity now. So let's talk about the difference between interpreted and compiled language. Let's talk about this first. So if you have ever written JavaScript before or Python, I asked earlier, nobody has written JavaScript or Python before. But if you ever written JavaScript or Python before, you should know that these languages are not what the computer understands. What I mean is that the computer does not understand these languages natively or traditionally. So all these
Please,
languages,
I'm trying to hear you, sir. Sorry.
okay, I'm talking about interpreted languages now. Difference between interpreted languages and compiled languages. Can you hear me now?
Yes, sir.
Hello. So
Yes,
I
sir.
see that.
Yes, sir.
Okay, okay. So I see that interpreted languages, or sorry, I see that normally if you write a program in Python, the computer does not understand this language. The computer does not understand the Python code you write, even the Java code you write. Java code you write, the C, C sharp, and so on and so forth. The computer does not do what, does not understand it programming because they are high level. The computer can only understand machine code, which are strings of zeros and ones. Another code or another programming language that is closer to what the computer can understand is called assembly language. Do you understand? For programs written in Python and JavaScript and so on, and not understood by the computer natively. So how does the computer now get to execute these programming languages if it does not understand what what they have? Are you getting it? So the answer is translation. So what is translation? Translation simply means when you convert the language from its form into another form that's understandable by the computer. For instance, if, JavaScript I told you about, JavaScript is not natively understood by the computer. So how does it work? When you run a JavaScript application, let's say a Node.js application, Node.js server, or let's say even your React application, what happens is that the runtime or the interpreter checks the code line by line and interprets it to the computer on the fly. So what I mean by on the fly is that it checks line one. Okay, this is what line one is saying. Line two, this is what line two is saying. It tells the computer, then the computer executes it, and so on and so forth. So this type of languages, we call them interpreted languages. So why do you call them interpreted languages? Because they execute instructions line by line. The instruction was line by line. So other examples of interpreted languages are Python. You understand? Now, the other types of languages we have are now compiled languages. So why do you call them compiled languages? Because unlike the interpreted languages, they don't execute it line by line. They don't interpret. What they do is they compile it to produce a binary file, and that binary file can then be run on any computer. So that's different between an interpreted and compiled language. So you can think of interpreted language uh, as you going to church, let's say you go to a church, you have a pastor teaching or preaching in English. Then you have another person, maybe interpreting in maybe any of Nigerian um, language like maybe Igbo or Yoruba. So let's say the pastor is saying, praise the Lord, the interpreter interprets it. So as the pastor is talking, the interpreter interprets when the pastor is saying line by line. So that's how the interpreted language work. Now the compiled languages on the other hand works like this. You get all the you get all the text, compile everything at once, then give it to the person to read. So I think that's a good analysis to explain difference between interpreted and compiled languages. Are you guys listening? Hello?
Yes, sir. We're listening.
Hello? Okay.
Yes, sir.
Now I've talked about interpreted languages and compiled languages. Now the other set of languages, we call them, they have what we call hybrid interpretation, or hybrid compilation rather. So example of such language is Java. So another example is what we are talking about today. So for them hybrid compilation. How are we coming? Because they get compiled get executed.
Sorry, sir. Please, I didn't
Are you
get what
getting
you
it?
said.
Okay, I've talked about interpreted languages. I've also talked about compiled languages. Now I'm talking about languages like Java and Solidity. So I call them hybrid. They have hybrid compilation. I think they have hybrid compilation. So what do I mean by hybrid compilation? It means that translation is in two phases. I get it. The first phase is the compilation phase. So what we mean by compilation phase is that the source code gets compiled into an intermediate form, which is called the bytecode. So a good example of such language is Solidity, which we're talking about. Another example is Java. So after getting them compiled to that intermediate form, which is called the bytecode, we now have what we call the virtual machine to interpret that bytecode to machine. So the bytecode is not machine. Remember, the computer only understands machine, but the bytecode is closer to the machine code than the high-level languages we write. So what they do is they compile them to bytecode. After combining to bytecode, during execution, the virtual machine will now do what and that's where we have the Java virtual machine and Ethereum virtual machine. So what the Java virtual machine does is same as what Ethereum virtual machine does. So they get the byte code of the source code themselves and do what interpret it to the machine. So these are the three categories of programming language based on how they are being worked, how they are being translated. Now aside from this, we also have attempt but that's really proof of class. I get it. That's really proof of class. So these are the three languages. These are the three translations. These are the interpreted languages. We have compiled languages, and we have hybrid compilation or hybrid compiled languages. So let's move on. So what's the difference between a normal program and a smart contract? Let's talk about the difference between a normal program and smart contract. So a normal program runs on traditional operating systems like Windows, Linux, Mac OS. So what it means is that a normal program, example of which is a Node application, a Node server in Node, a Python application, they run on normal operating systems like Windows, Linux, Mac, I get it. You understand? Now, smart contract on the other hand, they don't run on normal operating systems. I get because they're not designed to do that. So they run on what's called virtual blockchain virtual machine. Example of which is EVM. So learn how to ask the phone. You understand? Now, another difference is that what do you call it? Normal programs are centralized. I made mention of Web2, difference between Web2 and Web3 earlier on. I said that Web2 languages are the two applications that they are what they are owned by private organizations like Facebook, Google, Microsoft. They are what they are Web2. They have the application they run is Web2. Web2 in the sense that they are the ones controlling everything. They can manipulate anything. They can do anything with your code, and you will not even know. You understand? So normal programs are usually done on such servers, centralized servers, personal servers. Are you getting it? Servers of organizations. But smart contracts, on the other hand, are executed in decentralized manner across blockchain. For example, the Ethereum network. So that's about that. Now, another thing is immutability. That's another difference. What do you mean by immutability? The normal program can be updated. You can update it. That's when I was talking about manipulation. It is easy for you to manipulate. Now, I guess someone is better and sometimes, but it's not sometimes when but it cannot be like that. So you may want to ask that okay, what is then I start from they are doing the thing that it's not as if you are manipulating the third one. I get in but there are ways to go about it. But normally, normal codes are immutable. Smart contracts cannot they are what immutable, they cannot be modified. So that's what that point says. Also, another difference is that normal programs they rely on central entities for execution and stuff. So we have talked about this. For instance, all the bank bank programs too, they rely on the bank. You don't know what banks are doing behind it. The bank can try to think something because of I get it. So they go and say, you don't know what's doing behind it. So smart contract on the other hand are publicly disclosed. To see that anybody can read it. So as you have to do, you don't need the programming. Even if you don't have any programming, you can from what people are saying, you can say that okay, this is how this program is working, and so on and so forth. So the short term transparency, working between the normal program and smart contract. So that's another difference. Another difference is community education. Normal programs they can behave differently based on the environment. How a how a program based on English is different from based on Mac, different from based on iOS, different platforms. Just like your Android and iOS. Sometimes there are some code like the right on Android. But normally the right only code on Android can't work on iOS because they are different. Platforms are different. You have to target the platform when developing applications for both but I think iOS and Android. Although with frameworks like Flutter and the Apple target both of them at iOS. But then that doesn't change the fact that both you are writing platform for anything that is making itself as Android cannot come on iOS and that is that. So that's what I mean by the smart contract execute deterministically. Now also automatic enforcement. Normal programs require external enforcement. Okay, talk about something else today. So, um, blockchain. Okay, let's not talk about this. From what I've said so far, we've already mentioned some things that we explain all the things there, all the things there. So let's just go into Solidity. So, Solidity is a statically typed programming language. Statically typed. It's the object-oriented. I get it. And it is influenced by JavaScript, Python, and C++. So, what do you mean by statically typed? So, before we talk about that, or before we move into that, just like for every, artisan or for every worker, you need tools. Are you getting it? You need tools to work. So the same way as a programmer too, there are some things you need to put in place in order to, to work. So one of the things you need is an IDE. Now, in this session, we'll be making use of Remix IDE. It's an online IDE. Now, I could have, set up a local Solidity environment for this session, but then it is easier working with the online IDE than working locally because from the online ID you can easily visualize you can easily visualize what we are doing as compared to the local one where you just the same command line messages. So let's just let's use the online one. So if you're on your system, you can go to Remix ID. You can type Remix ID, click on it, click on the first link. Then you go. Sorry. Okay, okay. So it's not showing. So let's go back to the slide. So we're talking about Solidity, and I said Solidity is a practically typed programming language for writing smart contracts. So what are smart contracts? Smart contracts are programs that are written for the blockchain, written and deployed on the blockchain, I get it, compared to the smart contract. So what do you mean by practically typed? It means that for you to store anything inside the variable in Solidity, if I do maybe like I can see that how how so this thing this kind of I getting it. Okay,
So we didn't get you.
can you hear me? Okay. From where did
We
you
can hear
get
you
me?
now.
Okay, okay. Okay, I'm talking about the Remix ID. I see that this Remix ID now is what we'll be using for Solidity. Now, what I'm doing now is to walk you through the interface of the Remix ID. So teach you about the things to get started with Solidity using the Remix ID. So I see that here now you have the file system. This is where you're creating the files of your project. Now from this place here now, you can decide to create a new workspace. That if you have multiple projects you are working on. So here now is named or is labeled default workspace. If you have another workspace, you can create another one. I have another one here too. I get it. You can decide to create. You can create as many. You understand? Now on this place here now you have all these icons here. Give you even if you don't know what to do, they're going to give you info of the things you can do with them. For instance, this icon here means that you can create a new folder. So if I want to create a new folder, what do? I click on it like this, and I so let me call it Solidity. Can give it any name. So you can create your own too on your system. Also, if you want to create a file, over on the second icon, you can see it's called it is labeled create new file. So you can click on it and create a file. I get it. So that's that about this tab. Now, this one here, this tab here, is for compilation. Remember I told you that Solidity, Solidity translation is in two phases. The first phase is what? Compilation. Where it compiles to what? To five state. Second stage is what? That that is not our own system. I get it. Now we get sorted by the weakness when it started repeating the Solidity. So then to compile our Solidity body, all we have to do is what? Click on this field. Now we don't have any file to be selected. So that's why this button is. So the moment we select a file, it's going to be anything. It's going to be a- you understand what I'm saying? Hello. Hello.
Hello, sister.
Yes, sir. We get you.
You understand what I'm saying?
Yes, sir.
Now, the next app I want to show you this one here. So this one here is to run your program. So there's nothing to run here because you don't have any deployed contact. You can see you have zero deployed contact. So there's nothing to run here. So we are going to see all this things the moment we create a what smart contract. So let's go back to the file explorer. So sorry, the file explorer. Yeah, let me create a new file. Call it go to Solidity. Now, different files have different extensions. I get it. The extensions are just a way for the operating system to distinguish between different files. For instance, we have text file, then with PXT. So when the operating system sees a file ending with PXT, it knows that okay, this is a text file. If it's ending with MP4, it means that okay, this is a what? A video file. If it is MP3, it knows that okay, this is an audio file, and so on and so forth. So different programming language, they also follow that what? That pattern. You understand? So for instance, JavaScript uses .ps as a file extension. Python uses .5. Rust uses .rs. Solidity uses .sol. SOL or sol.
Dot
See
what,
that way.
sir?
Dot .sol .sol. Solidity
Dot
sol.
SOL.
SOL. Yes, SOL. You understand? So that's about that. So after typing the name, click on enter, and you're going to get and you're going to create it. I'm talking about statically typed and dynamically typed. So what do you mean by statically typed and dynamically typed? The languages like JavaScript, you don't have to tell the interpreter or JavaScript engine that okay, this is I get it. You don't have to understand. You don't have to tell it that I understand. But in languages like Solidity and other languages like C++, you must fit the type at the point of initialization. You must do what? Fit the type. You understand? So that's the difference between a statically typed language and a dynamically typed language. You understand? Now, let's have to write a solution program. The first thing you need to do is put a comment here. So let me talk about comments. In programming, when we see comment is a way of disabling a line of code. It's a way of preventing a line of code or a group of lines of code from running. I get it from running. So it's just a way of telling the compiler that okay, this code, don't touch it, leave it as it is. You understand? So that's what we call comment. Now, in programming, generally in programming, or do not in all programming languages, but mostly in programming languages, this is how you write a comment. And this style is called single line comment. Single line comment in the sense that it only affects one, it does not affect more than one. Now, if you have something like this, let's say you have four slides, asterisk, sorry, that's not asterisk, that's not. after every cafe, you have another forward part. This will be multi-line comment. So you can see, I can write anything, multiple things between these two, these two symbols. You understand? So you have to have something program. You have a multi-line and single line. Single line, you just, in fact, the moment you type it, you're going to see the color. It's, it's pink kind of color. So that shows that this kind of code is not going to run. So the way of telling the compiler that leave this line of code, don't run it. Are you getting it? Also, it's also used for documenting our code. For instance, if I have a function that is doing something and the function is very complex, I can use a comment to do what to explain the path of the function. So we come back to that later, but it's just to, because this program is starting with this comment. That's why I have to explain it. I get it, but it's not hard to. So
Hello everyone. Sorry, let me reconnect with the facilitator.
hello, hello, hello.
We can hear you. Can hear you, sir.
Sorry for the. So let's continue. Can you guys see my screen? Can you guys see my screen?
No, we can't.
Okay,
No, sir.
comment. Okay, can you see it now? Can you see
Yes,
it?
sir.
Yes.
Okay, so let's continue. So this is a very high topic. So SPDX, sorry, license, identifier. So I'm going to write in MIT. So this time here, we're not writing this first time. We let's not talk about it. Just write it. Just type it the way it is like this for now. If later, let's finish. So the next thing is tell the version of compiler which you are using. So that's the next thing. So how do you do that? You type in pragma solidity, CT. Are you getting it? Then you tell the version which you want to work with. So in our case, there are different ways you can do greater than or equal to, let's say, 0.7 or 0.80. Then less than or equal to, let's say, 0.11. The idea is also completing it. That means I work, or that means I code in fact. So the purpose of this time here is to tell the Solidity compiler or to tell Solidity the version which you want to work with. Are you getting it? That's the purpose of this plan here. To tell which version you want to work with. If you're working with version so specify it here. Now what's the meaning of this here? So this one here means that work with version any version that's greater than or equal to 0.80. How you getting it? 0.8.0. Any version that's greater than this or any version that is less than or equal to 0.11.0. So what it means is that if I should run this code here on the version 7 compiler, it is not going to run. It's going to give an error. Are you getting it? Because according from what I stated there, the 0.7 code should not run. So that's the meaning of this line. To tell the version of compiler which is compiling your code. Okay? So that's about that. Now, the next thing is to write track. Now, if I'm coming from Web2 background, have you ever written any programming language, let's say JavaScript or Python or Java, you can think of a class like a class. Are you getting it? You can think of a contract rather like a class, so they are similar. Are you getting it? The class is like a blueprint. So when we say blueprint, the format, the template for creating objects. That's what a class is in programming generally. So the same way, a contract is similar to a class. But the difference is that contracts are, are kind of specific to solidity. I get it. So it's just let me just say it's just a way of naming things, just the way solidity chooses to name its own, keywords. I mean they could have used class here too. Then they decided to use contract just to how will I put it? To show the name of what it really is. They are building smart contracts. So I think that's why they decide to use the keyword contract for this. So after contract, the next thing is the type in the name. So our this is completing it for us. So let me just intro. Let me type it out. So that it's good to type out as beginners. It's not good to just use them. There's nothing wrong with using autocomplete and all those things. But then as a beginner, it's good to do what? To type things out manually by yourself. So that you get used to it. Then as time goes on, you start using all these things. I get it. If it were to be only me, I would have, each tab and complete everything for me. But then as a beginner, always type in things by yourself. For yourself by yourself. I get it. Don't always rely on autocomplete. So let's move on. So introduce solely. So if you observe this name here, we see that the first character of each word is written in capital letter. So this is what we call past classes. Past classes of naming things. So this character here is capital letter. This character here is capital letter. This character here is capital letter. So it's not a strict rule. So what I mean by it's not a strict rule is that you can try to use one letter also. You can try to use the mixture of capital letter and write it anyhow, but then it's a convention. When they say something is a convention, convention does not mean something you must follow. If you don't follow it, it will not lead to an error. But then it's something you should follow. It's something that is generally accepted. So that when other people are reading your code, they will be able to read. So convention is something that is expected, something that when other people come and see a code, that's what they expect. That okay, they are naming a contract. This is start starting. I get it. So it's just a rule. It's just a normal rule, it's not a strict. So that's the difference between a convention and a strict rule. So you can try to name this intro to for anything anyhow, but then follow this pattern. It's called factor space. So anytime you are naming your contract, it's factor space. And the other case is like camera space, which you are going to explore after the work. So the next thing is to do what? You hit enter. You understand? Now, after that typing your intro to Solidity, you have to close the curly braces. I recommend. So you can see this one where is opening brace, this one where is the closing brace. So let's have a normal thing in programming. I get in as the beginning as a beginner. How would I put it? As a first step to every programming language. You know, when learning programming, the first thing you do is you learn how to say hello world, just like you did it as a child. First thing is when you go to school, first thing is you learn how to say it, you learn how to type two-letter words and so on and so forth. So the first step in programming, mostly for everybody, is saying hello world. And you can try to just say agree your name, but then this is what everybody is saying. Just print hello world. So let's do the same thing. So let's do the same like this, public like this. Then okay, let's call it written also. Written. Then equal to hello world. Hello world. So congratulations. If you have been typing along with me, you have successfully written your first smart contract. So this is a smart contract that has one fixed variable and the fixed variable says hello world. So let's try and run this. Sorry, this is supposed to be a colon, not an item. It's supposed to be a colon. So that's one of the things you face as a programmer. Sometimes it says bug. So programming is not always smooth. Sometimes it says bug. So that's it. So it's just a part of learning. I get it. Thank God we encountered this. It's also part of learning so that you know that okay, when you see this kind of error, I've given you it now. For instance, when I had ICL, what did I do? I placed my cursor on this line of code, this place there, and I saw the message. SPDX license identifier not provided in source file before publishing. Consider adding a comment containing SPDX license identifier colon. So you can see this line here gave me clue of what to do. I getting it of the mistake I made rather. I knew what to do, but it gave me of the clue of the mistake I made. So it's part of the learning. So you should take note of that. So the next thing now, after writing our smart contract, is to compile it. Remember what I said that the computer does not understand all these things you write natively. I get it. So they have to be what converted into a form in which the computer is going to understand. So, which is what we want to do now. Compile, you go to this tab here. I showed you this earlier. I showed you this earlier. So, if you click on it like this, from here you can select the compiler which you want. Are you getting it? You can see by default 0.826 is selected for us. Let's choose latest version. Okay, this is the latest local version. Okay, let's go with this. Let's keep it. Okay, you can change it based on the requirement. You can try to go with this. Are you getting it? So if you go with this, it's going to change it. You understand? You will not click on this button here until it has finished changing it. You can also change it. Let's change it back to this. So you have successfully changed it. So for us to compile, it's just a click away. All you have to do is click on this and get your smart contract compiled. So the moment you see this green tick here, it shows that your smart contract is what compiled. Now I talked about bytecode earlier on. I say that programming languages like Java and Solidity, they don't get compiled into native code. They get compiled into what bytecode. So if you move down, if you go down, if you scroll down, or you move down, you see these two copy buttons here. The first one is doing ABI. So I'll talk about ABI shortly. Now, this one here is saying bytecode. I get it. So this is the bytecode I was talking about. So the bytecode is what you deploy to the blockchain. Is what you deploy to Ethereum network. Are you getting it? So this is bytecode. Now let me not talk about ABI. So ABI is just a way of interacting with the smart contract. So what do I mean by interacting? We have different types of. It fully means application binary interface. That's the full of ABI. Application binary interface. Let me go again. Application binary interface. So what does it mean? It simply means we have different ways of different ways of interacting with applications in computer. I get it. One way is GUI. So when we say GUI, so far all I've been doing is using GUI. What I mean by GUI is I come here, I click on this, I move my mouse here, I click on this, and so on and so forth. For me to compile, I'm not typing anything, I'm just clicking on a button. So all these ones here, they are GUI, called graphical user interface. So graphical means something you can, something you can visualize, something you can see. So that's basically what GUI is. Do you understand? Now, other types of interface is command line interface. So if I was to do it locally on my system, I won't be clicking all these things here. I'll be running commands. I'll be running scripts on the command line. Are you getting it? I'll be using the terminal. Let me give you an example. So I come to this program and I open CMD like this. I click on it. For me to interact with this thing, I have with this terminal rather, or this command prompt, I have to use what? Prompt. Are you getting it? If I do CD, or if I do DI out, it's going to list all the directories in this current folder for this. If I click on it, it will list everything. So I have desktop, I have documents, I have downloads, and so on and so forth. I can try to navigate into the desktop. If I do CD desktop like this, and I hit enter like this, I'm already in the desktop. So this is what we call command line interface because we are not using mouse to drag and drag. We are not using mouse in that. We are using what command. That's it. Now another way of interacting is what we call this API here now. Now, if you have written code in Web2, let's say in Java 2, the front-end developer uses programming languages of the programming language JavaScript. That's the new language, right? Then maybe frameworks like React, Vue.js, or Angular. So the programmer uses those languages and frameworks to create something good for the user to see. I get it. Now, in order to now interact with what the backend developer has done, the backend developer has to do what? Expose something from the backend to the front end person. So how did the backend person expose the things he has done at the backend to the front-end person? That's through the use of what? API. So that's where you see the backend developer giving the front-end developer endpoint. I get the API endpoint. Okay, take this endpoint. With this endpoint, you can communicate with this backend on so things. Let's say the front-end developer wants to implement login functionality. So if I'm the backend developer, I can give the front-end developer an API endpoint for login, and the front-end developer will be able to do login. So the the front-end developer is not communicating with my backend code directly, but it's communicating through the what API. So the API is an interface, just like the command prompt I told you just now. Command prompt is the interface between you and the system. Are you getting it? Between you and the operating system. So it is the operating system that executes all those things to do for you. But then you can't communicate with it directly. It will be a pain in the ass for you, having to do with the operating system in crude version. You understand? So that's why you make it of the command line. So the same way the front end can communicate with the backend API through what? API.
So,
So the same way
so,
you have hello,
I was struggling to hear you,
hello.
honestly. I was struggling to hear you. I don't know. Can you hear me?
What do you hear? I'm struggling to hear me.
Can you
Can
hear
you hear me
me?
now? Can you hear
Yes,
you? Hello? Can you hear me?
yes.
Okay, at one point did you stop hearing me? Hello? Hello?
Hello, I can hear you.
Hello? I said
Yeah,
at
I
what
can
point
hear
did
you.
you stop
Can you hear
did
me
you
now?
stop hearing me? I can hear you very well. I can
No,
hear you
I'm
clearly.
saying
I'm
like I
asking you
was
at what
hearing
point.
you.
Hello?
No, like from the beginning of the class, I was trying to hear you more. You were talking, but I don't know if it's from your own end, but I can't really hear most of the things you were saying, though. Most of the things it was
Oh,
actually hard for me to
sorry.
like grab some things that you were saying.
Okay,
So I really
what
don't
of
know.
others? Can you guys hear me? Or is it the same thing for everybody? Hello? Hello?
So
Hello.
basically,
Can you
I can
guys
yeah,
hear
hear
you.
me?
we have the same issue, but you it's as if your volume increases and lowers.
Oh, okay. I will. I've not touched my volume since. But you guys can hear me now. Have you?
Yeah, we are.
Okay. Okay. Let's continue. Okay. I was talking about API and API. think API is for the normal Web3. How front-end applications react to back-end applications. But API is for smart contracts. So if you want your front-end application written in React or VJS or AngularJS or even in vanilla JavaScript to interact with your smart contract, you need the word API. So API is just like uh, it's analogous or it's synonymous to the API, the endpoint you get in Web3. You understand what I'm saying? So that's what I'm trying to say. So to run this your application, having compiled it to run it, you come to this tab here. You click on deploy and run. So after clicking on it, click on deploy like this. So the moment you click on deploy, the moment you see this green tick here, this green tick here shows that the program is compiled successfully. Same way, this green tick here shows that it is deployed successfully. Are you getting it? So when you see this green tick here, it means it is deployed. That means you can open it and you see your greeting. So if you click on this greeting now, you are going to see a yellow word. Let's try it. Hello world. Can you see hello world? So that's it. So congratulations, you have successfully written your first smart contract, which is hello world. Now, before we continue, let's talk about the part of this program, of this line of food rather. So I've talked about contract and intro to sustainability. I think this one here is fast case. That's like mentioned. It's a convention. Convention in the sense that you follow it, but it's not strict. Even though you use lower case also for this intro to solidity, it's not going to make any difference. I get it. For readability purpose and for maintainability purpose, and also for collaborative purpose, in order for you to be able to collaborate with other developers, the developers like you should follow the standard, which is using what? Fast casting. So that's the reason why we are writing it this way. Now, this kind of code here, let me explain this time. Remember I said that solidity is statically typed. So what we mean by statically typed is that you have to tell the data type of what you are declaring, or the data you are declaring before using it, before even assigning anything to it. So that's what I mean by what statically typed. If you are coming from the background of JavaScript, I can do something like this. Let's name equals 2b like this, and I will not be wrong. Are you getting it? I'm not telling JavaScript that okay, this is the website. I'm not telling it anything. I'll just type in this and I will be correct. Why? Because JavaScript was dynamically typed. Are you getting it? You don't have to tell it that okay, this is the type of this data. Once you type everything, it's going to automatically infer it. You're going to type infer it. Going to infer it that okay, this is what this is. And even if you change it, it's still going to affect the arrows. Are you getting it? So that's the level of statically typed language. So as you can see, we are having string there. So this string we are having here is telling us the type of data which this variable is holding. So when you say string in program, a string is a sequence of what characters enclosed in quotes. So we check this one here. You can see opening quote here. You can see another quote here that closes it. Are you getting me? So the sequence of all these characters there is what we call what? Yeah, quotes. So it's called strings together like this. So for you to store strings, you have to use the string word data type, which is this one here. So for you to declare a string variable, start with string. Now, the next keyword there, mind you, strings, public, contract, fragments, ability, they are all keywords. Are you getting it? Keyword. What do you mean by keyword? Keyword simply means that these things there, you cannot use them anyhow. You cannot use public anyhow. You cannot use string anyhow. You cannot use contract anyhow, and so on and so forth in a Solidity program. So what I mean by using them anyhow is that if you take this one here, this brick here is having white color. If you take this one here having different color, this one here is having white color. Now, in this case here, in this case here, this is having this here. I cannot use a keyword as my variable name. That's one of the rules of programming. You can't use keyword as variable name. Generally, are you getting it? In most programming languages, I don't know if there are programming languages where you can use keyword. Then, in most languages I've seen, you can't use what keyword as a what variable name. Do you understand? So that's that about keyword. So I've talked about the string. So string tells us the data type, the type of data which a variable is what holding. So in this case, this variable is holding what? A sequence of characters. So it's called a what? String. Now the next keyword is called public. It is called within a smart contract and outside the smart contract. So in this case, you are having public. So public simply means that this variable here is free to be accessed by anybody. Whether the function is accessed, whether the variable is being accessed inside this contract or outside of this contract, it is free because it is what public. It's analogous to anything public. When they see something is public toilet, are you getting it? It means that anybody can use it. You understand? But when you say something is private, not everybody cannot use it. For anybody to come and use, they must take a permission. Are you getting it? So that's just the uh, that's just how it works. So this public simply means that you can use it outside. Do you understand? Now another um access specifier I can put there is private. If I make this one a private like this, if I make it private and I recompile it, let me go back and recompile it. If I recompile it like this, it has successfully compiled. If I go back and deploy it and run, if I deploy it like this, that's successfully what deployed. Now if I come to this place and I click on this thing here, I won't be able to see it. Why? Because it is private. It is what? Private. Private simply means you can't use it outside of this contract. You can only use it to see the contract. Do you understand? So that's that about that. Hello. Anybody want to say anything? Hello. So let's continue. So that's that about that. So another example. The moment you start having decimal points attached to a number, it no longer becomes it is no longer an integer. It now becomes a what? A floating number. Do you understand? So let me make this one a public so that we can see it. Public like this. So it's like this. And also mind you, every line of code is terminated with semicolon in Solidity. Are you getting it? It must be terminated with semicolon. If there is a Python or JavaScript also allows the use of semicolon, so it does not enforce it. You understand? Python not so that's about that. Let's run this contract. Let's deploy it. Let's compile it first. If I compile this contract, this green switch here shows that compiled successfully. I go to this deploy tab and I click on deploy like this. It's going to get deployed. So I come to this place here and I click on this drop down on this accordion here. I drop down. You can see
Sorry,
it
sir,
here.
I can't see your screen.
You can see my screen. I'm playing my screen already. Okay, let me stop my share again.
I'm seeing it now, sir.
Okay. So but you can hear me clearly, Abby. So let's continue. So this is age here now. If I click on age like this, you can see age is what? Age. Yeah, age is also what? Age. You understand? So that's about that. So public simply means that you can access it outside of the smart contract. Private simply means you cannot access it outside of the what? Smart contract. That's the difference between public and private variables. You understand? Now, not just variables that can be public and private. Functions can also be public and private. You understand? Private. Now, one last thing before we call it, okay? We're already using the time for Solidity. So let's just round up. Solidity programs also have what we call constructors. We have functions, we also have constructors. Are you getting it? So when we say a constructor, in normal programming, the constructor is function. Are you getting it? In programming languages like JavaScript and Java, Constructors usually have the same name as the class, with the exception of JavaScript. Constructors usually have the same name as what as the class. So in this case, now if we get to Java, this constructor I'm writing here will have been the same thing like this. I getting it. But then it's not the same way in Solidity. You use the keyword constructor to show that you're writing a word constructor. You understand? So that's it. So constructor is a function, a method rather, that is invoked at the time of what? Deploying. So the moment it is deployed, you need to what? Invoke it for you. You're going to invoke it for the CVM is going to call it for you. That's what constructor. Other functions, you have to manually call them. But then this one here, it gets called for you. The moment you what? Deploy it. The moment you run it, it's going to be what? Called for you. That's the difference between a constructor and a normal function. So in this constructor now, you can initialize the values of your state variable. For instance, here now, if I don't want to assign age to this list, I can come to this my constructor here and assign the value to it and make it like 300 like this. If I come to this place and compile it, it's going to tweak green, showing that it's successfully compiled. If I come to this deployment tab and I click on deploy like this, it's going to be deployed. Then if I come to this place to inspect the variables, you can see we still have it, and on click of it, you get to see what 100, which is what we assign there. You understand? So constructor gets called for you at the time of what deployment. That's about that. So let's call it a day. Let's stop here. So far I've talked about the difference between interpreted language and compiled languages. I will talk about how Solidity translates its own code, how Solidity code gets translated. I said it uses what hybrid compilation. Says that first get translated or compiled rather into what we call byte. So the byte code is similar to the machine, but it's not machine. It's similar, it follows the same pattern like Java. Java also uses the same pattern. So both compiled to what byte code. And the byte code now gets what executed by the virtual machine. In the case of Java, it's called Java virtual machine. In the case of Solidity, it's Python virtual machine. So I talked about that. Talked about the difference between the normal program and smart contract. I also talked about what did I talk about? Let me go back to the slide. So I talked about the difference between this and this. I talked about the difference between the what do you call it? Um, centralized and centralized. So we covered a lot, so we can't cover it all. And we also talked about, we also worked on some of the syntax, the basic syntax of Solidity. So I think this is good. Thank you for your time, everybody.